You are very familiar with the four mathematical operators: plus, minus, divide by, and multiply. You're comfortable with how they are used and take for granted that they work with all numbers. But in computer science, all symbols must be defined, and further defined for each data type with which they will be used. In Java, there are two operators defined for integer division. And the two operators look like this, and you would call that regular integer division, and the percent sign is used to represent another kind of division called modular division. Recall that we are only talking about integer data types, just as it does not make sense to talk about what it means to divide one word by another word in the English language. The only data type that defines two different types of divisions are any integer data type. Here's some examples. If we were to write 7 divided by 2, we would say that that's 3. Now in a math class, you'd probably say that that's 3.5, but just hang on for a little bit. If I were to write 7 mod 2, the answer to that is 1. And here's where this comes from. If you took the number 7 and when you were first learning long division, you divided that by 2, you would ask yourself, how many times does 2 go into 7? And you would say it goes in 3 whole times. 3 times 2 is 6. 7 minus 6 is 1, and 1 is less than 2, therefore your answer would be 3, remainder 1. And so, this is what we mean when we say 7 divided by 2 when we're talking about two integers. This is what we mean when we say 7 mod 2. So it's called modular division, abbreviated mod. So this means number of times the divisor goes in fully. That's not too neat, is it? This means the remainder when the quotient is divided by the divisor. So here's some examples. mod 5. We're looking at modular division. We are asking what's the remainder when 12 is divided by 5. And 5 times 2 is 10, and then you have 2 remainder. Okay. What is 14 mod 7? Well, 7 goes into 14 evenly, and so what is the remainder when 14 is divided by 7? It's 0. So it's fine to have an answer for modular division as 0. What is the answer when I say 2 mod 3? Okay, well, that would be 2. 2 divided by 3, it goes in 0 full times, and with a remainder of 2. If I were to say 2 divided by 3, that's 0. It's not 0.66. So I'll start over on a new screen with some examples that are similar. So if we have 13 mod 4, we now understand that that's 1. 13 divided by 4 is equal to 3. But how do you know if you're dealing with an integer or a double or what? So you know because there's no decimal point. There's no decimal point right there. There's no decimal point right there. This is an integer, and this is an integer, and this is a binary operator, which means it takes something on the left and it takes something on the right. And so if we have an integer on the left and an integer on the right, integer division is performed. Now let's say that we have 13 0.0 divided by 4. We have the same symbol that we had up here, but we have a 0.0. So we have now a double, a real number, a floating point number on the left, and an integer on the right. So what happens? So here's the rule. When at least one of the values is a double, the whole operation is a double. So 13.0 divided by 4 is equal to 3.25. 13 divided by 4.0 is equal to 3.25. 13.0 divided by 4.0 is equal to, guess what? 3.25. And so, let me restate again, if at least one of the values in a binary mathematical operation is a double, then the operation is a double. Let's consider 13.0 mod 4. So we have a double over here and an integer over here. Now, your computer will not give you any trouble with that. But what I want you to do is you are going to say that modular division is not defined for doubles. Okay, so this has one of the operands as a double, the other as an int. If at least one is a double, then the operation is performed as a double. Integer division, modular division doesn't make sense for doubles. Okay, so separately, let's do one more example in this regard, and let's have 18 mod 5 divided by 2 plus 1. So you've already done some operator precedence things, so how does modular division fit in with the whole thing? Well, modular division, and multiplication are all of equal precedence. So if I have two types of divisions in a row, then I go left to right, okay, like you've learned in your previous things. So 18 divided by 5, 18 mod 5 is 3. 3 divided by 2 is 1. 1 plus 1 is 2. So the answer is 2. Remember, we've already defined casting to be the process of temporarily casting a variable to a different kind of data type. So let's consider the following lines of code. Let's declare an integer, call it total, and assign it 10. Let's declare another integer, and let's say that that's named sum, and let's say that we either assigned it 232 like this statement is doing, or we have added up a bunch of numbers and got 232. Let's have a double, and we'll call it average, and we are not going to fill that with anything quite yet. So say we want average to represent a value accurate to the 10th place. We want it to be a double. We've declared it a double. And say that we want this value put into average as 232 divided by 10. Well, 232 divided by 10 is 23.2. So it shouldn't be any trouble, except you do need to cast, because let's make this line of code. Average is assigned double. We are temporarily casting one of these as a double. Sum divided by total. So let's go through exactly what happens. Sum is an integer. Total is an integer. If I do integer divided by integer, we get integer division. It would have been 232 divided by 10. Well, that would have been 23. It's not what we want, though. We want 23.2. we want it to be a double as an answer. So this is the syntax to do that. I am casting sum temporarily as a double. So we have on the left hand side, we have a double divided by an integer. If at least one is a double, then the operation performed is a double and results in a double answer, and it is assigned to average. If we would have just written, and it's a very common mistake, sum divided by total, here's what would have happened. Sum is an int, total is an int, we would have gotten 23. We assign that to a double, so we think that the computer is smart enough to know, well, we really meant 23.2, but right here, this operation occurs first, which is an integer division operation. Whatever the result of this, which is an integer, is assigned to average. So you might think that this kind of would have a 23.0 in your brain, okay? But it's definitely not 23.2. So we do not want to make that mistake. There will be some more examples in class, lots of examples with casting integers to characters and back. Okay, we'll go both ways, and there's some tricky bits that we will definitely pay attention to.